we want to know if a point lies on a line. We know how to plot a point. We know how to find the table of values given an equation, and we know how to plot those points so that we get a line. But how do we know from an equation if a point is going to lie on that line? Let's say we have the equation y equals 3x plus 6. Does the point 1, 4 lie on this line? Of course, we could do what we just did before. We could draw a table of values, we could sub in the numbers, we could plot the points and draw the line, and then we could see whether or not this coordinate fit onto our line. That's very complicated though. There must be a better way to do it. If we think just a little bit, maybe some of you have already figured it out. If I draw a table of values, I then use those points to plot on my line. So what if I just said, well, if that's x and that's y, I know that y equals 3x plus 6. But y should equal 4 and x should equal 1. So 3 times 1 plus 6. So 4 should equal 3 times 1 is 3 plus 6. 4 equals 9. Well, 4 doesn't equal 9. What does that mean? That means that if I substitute in x equals 1, I don't get 9. So it doesn't work. If it doesn't work, then my point is not on the line. Therefore, because 4 doesn't equal 9, 1, 4 is not on the line. What about another one? Stay with me. If you don't get it 100%, that's all right. Stay with it. What about, does the point 2, 12 lie on the line? Y equals 3x plus 6. This time we know that x equals 2 and y equals 12. Let's substitute them in. Y equals 12, 3 times 2 plus 6. So 12 equals 3 2s are 6 plus 6 is 12. Well, that's correct. 12 does equal 12. Therefore, we know that our point lies on the line. Therefore, the point 2, 12 lies on the line. So if you're ever asked, does a point lie on a line, all you need to do is to sub in the x value, sub in the y value, and then see if it works at the end. See if the left-hand side equals the right-hand side. Here, 4 didn't equal 9, so the point was not on the line, it didn't work. Here, 12 equals 12, so it works, which means that the point does lie on the line. Sometimes they make you work backwards in maths, and working backwards is always a little bit more tricky than working forwards. Let's try a question that works backwards when a point lies on a line. So what if we get a question that looks like this? A point 1, 4 lies on the line y equals mx plus 6. Find the value of m. Looks a little bit daunting, but we know that they're talking about a point that lies on a line. And as soon as we see anything, or we understand that the question is asking us about a point that lies on a line, we know that we need to sub in the x value, sub in the y value, and everything should work. So let's see what happens if we do that. We know that x equals 1 and y equals 4. This is our equation, y equals mx plus 6. But we know that this point should lie on this line. So when x equals 1, that's a 1 there, that becomes 1m, or m times 1, plus 6, and y equals 4. So 4 equals m times 1 is m, plus 6. Well, now this should be an easy equation to solve. I just need to move the 6 to the other side, so the plus 6 becomes a minus. 4 take away 6 is minus 2, so m equals minus 2. And that's it. So what seemed like a really complicated question was actually quite simple. Thanks everybody for watching my new video. Don't forget to like and subscribe below.